What are you doing here?
I am here to participate as a person who's willing to break the enigma machine of data management as being the most difficult problem of the world.
Everyone said that the enigma of data gathering is unbreakable.
Great! Let us try. I've encouraged them to let us break the enigma, so I am expecting that each one of us know the things behind the code.
So, the first thing that we need to get is to analyze what is the measures of variation. I know. I remember that this measure of variation or described as the width of the distribution. It defines how spread out the values are in the data set. This also has 6 measures of variations. First is the range, the quartile deviation, interquartile deviation, mean deviation, variance, and the standard deviation. So great, that saves the first part of the code, but we still have so many things to solve.
Here's the other one. The interquartile range is a measure of statistical dispersion, which is the spread of the data. The IQR may also be called the med spread, middle 50% or H spread. It is defined as the difference between the 75th and 25th percentile of the data. For example, consider the following numbers 1, 3, 4, 5, 5, 6, 7, and 11. After we remove observations from the lower and upper quartiles, we are left with 4, 5, 5, and 6. Then, the interquartile range or the IQR would be 6 minus 4 is equal to 2. So 2 is the answer.
Here, I got it. Being said that the range shows the difference between the largest and smallest values, and it is a set of data which is the result of subtracting the sample maximum and minimum. And to get the range of a specific problem, we have to first put all the numbers in order for them to subtract the lowest number from the highest, and the answer provides the range of the list. Mathematically, we can define as, or its formula is, quartile deviation is equals to Q3 minus Q1 divided by 2. Example is the following numbers. We have the set numbers of 22, 12, 14, 7, 18, 16, 11, 15, and 12. First, we have to arrange the following set in order for us to get a quartile deviation. So as we arrange the numbers, it will turn out as 7, 11, 12, 13, 14, 15, 16, 18, and 22. Then, after arranging the set, we will find the Q1 with the formula of Q1 is equals to 1/4, open parenthesis, n plus 1, close parenthesis, and its term. So first, we will show what's inside the parenthesis, so it will turn out as 1/4 times 10. So the Q3 solution, we have Q3 is equals to 3/4, open parenthesis, 9 plus 1, close parenthesis. So we solve it as how we do in the first quartile. So we will add first what's in the parenthesis, so it will turn out as 10. So we have 3/4 times 10. The quartile 3 is 7.5, which is its term. After getting the Q3 and the Q1, we will now proceed to the main formula. So we will substitute each of the numbers and we'll solve it. So it will turn out as open parenthesis 17 minus 11.50 close parenthesis divided by 2. So considering the fact that we need to solve what's inside the parenthesis first. So 17 minus 11.50 is equals to 5.5, and then we will divide it into 2. So our quartile deviation is equals to 2.75. We almost solved the code, but we can see here that we still lack of information about the variance and standard deviation.
I know those. A variance, the average of the square differences from the mean. To figure out the variance, calculate the differences between each point within the data set and the mean. Once you figure that out, square and average the results. For example, if a group of numbers ranges from 1 to 10, it will have a mean of 5.5. If you square the differences between each number and the mean and find their sum, the result is 82.5. To figure out the variance, divide the sum 82.5 by n minus 1, which is the sample size, in this case 10 minus 1. The result is a variance of 82.5 over 9 equal to 9.17. Well, the standard deviation division is a statistical measurement that looks at how far a group of numbers from the mean. Put simply, standard deviation measures how far apart the numbers are in data set. For example, the mean of the following two is the same: 15, 15, 15, 14, 16, and 2, 7, 14, 22, 30. However, the second is clearly more spread out. If a set has a low standard deviation, the values are not spread out too much.
You're almost there. Almost there, I guess. Now, the Z codes.
Here, I got what Z-code is. I remember that it measures how many standard deviations. Below or above the population mean, a row score is called the Z-score in order to use a Z-score that mean and also the population standard deviation should be known. A and Z-score helps to calculate the probability of a score occurring within standard normal distribution. It also enables us to compare scores that are from different samples. Example, the T-score is 190. The T has a mean of 130 and a standard deviation of 30. Find the Z-score. Assume it is a normal distribution. Solution. Given T's score, X is equals 190. Mean is equals 130. Standard deviation is equals 30. So, Z is equals to test score minus mean over standard deviation is equals 190 minus 130 over 30 is equals 60 over 30 is equals 2.
So let's get through this. The Z code is right. We only have one left to know until we already broke the enigma of data management.
The box in a whisker plot. I know what it is. A box in a whisker plot is defined as graphical method of displaying variation in set of data. In most cases, a histogram analysis provides a sufficient display, but a box in a whisker plot can provide additional detail by allowing multiple sets of data to be displayed in the same graph. For example, suppose you wanted to compare the performance of three lots responsible for the rough turning a motor shop. The design specification is 18.85 plus negative 0.1 millimeter. Diameter measurements from a sample of shots taken from each roughing lot are displayed in a box in a whisker plot in figure 2.
Okay. I guess we're all done. Let's check.
I need a new message. The latest intercept.
So that's what we only need to know to break